All right, everybody, good morning and welcome back to the KSR YouTube channel. We're in the shop first thing this morning. Sun's been up for just a little bit, but got the kids dropped off at school. But we're back on the Cutlass for today's video. I also have another video on Soccer Mom coming out, hopefully pretty soon. I filmed it, I just have to edit it. So, but I'm gonna put this video out first. So let's get into some of the new stuff that's come in for the car while I haven't been doing videos. And then something real exciting is happening later today. At least I think it's real exciting. We're gonna play with some lasers on my engine. That's exciting stuff. All right, let's get to it. All right, well, since the last video, I've gotten my vacuum pump in, got my fuel pump in, same air motive, I think 12 gallon a minute fuel pump that we run on Soccer Mom, as well as a Moroso 4-vane vacuum pump. And then we've gotten in some of our belt guides for our Jones pulleys. And this is the pulley that is going to mount on the oil pump, which is right here. And what we're going to do, which I kind of mentioned before with the 4 belt setup, that won't slide like that once I tighten up the set screws. But basically, we are going to have the crank drive. Let's just do this here on the bench. So, crank drive is going to have a large belt that runs around there to there. So the lower, one of the pulley alignments, you know, and these aren't set right because they're obviously not bolted to the front of this. But that's going to go there effectively. And then the vacuum pump will be up here somewhere, mounted to, you know, mounted to the front of the motor plate. And then there will be a belt. It's going to have to be a little bit longer one. A belt that goes from there around the vacuum pump. And then the fuel pump will be somewhere over here on the other side of the engine, and then the alternator somewhere over there. Which, you know, probably alternator ends up over here, fuel pump down here, depending on steering rack clearance. But yeah, a lot of engineering and stuff that goes into that. At least I call it engineering. I'm certainly not plotting it all out in a CAD program like you just might see a little bit later in this video. But some of the stuff that I've got to work out and plan for and mount, and I've ordered the material for my motor plate since I didn't have the one that I thought I had. So we're going to have to make a motor plate, you know, do some fabrication on cutting a custom motor plate for this thing, which it's just 1/4 inch plate. It's not that big a deal to chop something up. And the nice thing about an Oldsmobile is the front plate here is completely flat where the motor plate mounts. So it's nice and easy to actually fabricate something and then, you know, drill a hole for where the water's got to go in and out of the engine. Let's just pull this out. So yeah, as you can tell, completely flat. And right now my plan is to have my motor plate kind of come up and it'll come around here, because these 2 bolts right here, I've decided I'm going to modify this bracket from MSD, do some trimming, and then we will drill holes in it that'll match up to these screws. It's the ID anyway. Basically that's going to mount almost flush onto there. May have to do a little custom machining, but we're going to make that work. And if I can't make this bracket work, I'll just make my own bracket that connects these 2 and then hangs the crank sensor, you know, somewhere right here to pick up the trigger wheel on the front of the balancer. So I've also gotten my pulley in, which not thrilled about. You guys may not be able to hear that, but this is loose in there. And being that the mandrel drive is going to sit on the front of this, I want this to be really tight in this here. You can kind of hear that slopping around in there. I'm not a fan of that. So I'm going to have to machine a different ring, the adapter ring, to tighten that all up a little bit. But like we showed you in another video with our Holley 12-1 crank trigger, that's how we're going to set that up so that this ends up somewhere right in here. And then that puts both my crank and camshaft sensor right up top here, and we'll probably run them back, the wiring back up under the intake manifold there, because there's going to be a valley tray, and the intake will bolt, you know, on this flange up here, and just the intake will come off. So the water lines will stay attached, just like an LS engine. I may even drill and tap the water in from the front of the cylinder head, just to give me some more room, because you can kind of see that's the bolt for the intake manifold, that's the water hole. I could drill in here and tap this and put water in from the front of the, or this is actually going to be water out, because the water is going to feed. I don't know if I'm going to feed the water in from the bottom. I haven't really decided yet. But these cylinder heads are dry decked, so they have there's no water that goes between the cylinder head and the block. So the gasket is a solid piece of copper. The heads are actually welded, have some plugs welded to them to make them perfectly smooth. Same with the block. When Bill machined the block, he machined these CNC pockets and then presses in these aluminum slugs, I guess you want to call them, aluminum plugs, that fill in the block so that there's absolutely no water that goes in between those two. Now the reason for that is when we're really leaning on this thing, because just like an LS, an Oldsmobile only has 4 bolts around each cylinder. So you can see 2 of them here, 1, 2, and there's another 2 up here. There's only 4 bolts per cylinder holding the heads down on this thing. So if I do shove a head gasket out of the thing, I'm trying to keep from putting water under the tires. So the way the water setup works on this thing, you could literally take the cylinder head off of the engine with the water lines hooked up, and it will not leak any water. Now, granted, I hope I don't do that. I don't want to blow the cylinder head completely off the engine, which is pretty much impossible, but I don't want to blow the head gasket out and blow water everywhere like we've done several times on Soccer Mom. Thankfully, it hasn't gotten us into trouble on Soccer Mom, and that's something we hope to continue in the future. But that's just a quick update on some of the stuff we've got. I also have to, one last thing, you can see I've got my MSD coils in for the car. I went with the Pro 600, which is right now the biggest and the baddest setup for individual coils for an engine. And I'm going to have to figure out what I'm going to do with mounting these things. Maybe it goes like this here, and make my little, work up my little short plug wires. One nice thing about an Oldsmobile, you can see the plug wires are nowhere near the headers, because the headers are going to tuck down, so it should be fairly nice to my spark plug wires, because with the LS's and small block, big block Chevrolet, small block Fords, all of those, especially when you put big time heat into the turbo system, they cook some spark plug wires. Well, I hope I don't have that problem. Now, of course, with this being a unique engine, I don't get to buy just one set of spark plug wires. Being that I'm going to do a drag and drive event, I'm going to have Firecore build me some spark plug wires, but I'm going to have to order 2 sets because I definitely want to have a spare set of plug wires. So, enough blah, blah, blah about that. Next part of the video will be something that's pretty unique about what we're doing with this project. and I'm excited to show you what that is. So here we go. All right, well, like I was talking about earlier in the video, we're doing something futuristic. I guess it's not really futuristic because now is the future. And I was talking about some lasers earlier in the video, and I've got one of my Oldsmobile buddies up here. Actually, it's down here for you, right? Yeah. So he is an expert CNC machinist. Is that saying too much? I know you haven't been doing it too long, but like you're really 3 years. Still, kid's awesome. But this is him. This is Peyton.
What's up, everybody? My name is Peyton. I am the owner and founder of Performance Driven Design LLC in the middle of nowhere, Tennessee. We do everything from mild to wild with laser scanning, CAD CAM, reverse engineering.
Yeah.
And of course, like Kevin, I have no common sense, and like Oldsmobiles, we like to have something very difficult and that you can't get parts for.
Well, let's show the people some of this trick stuff you got.
So, this is a Creaform 3D Handyscan 700. This is often referred to as a metrology grade 3D scanner. This does not come with the ISO 17000 certification, which is not necessary for what I do anyway, because I'm not trying to do, even though I'm using some rocket technology, I'm not trying to do rocket stuff.
Yeah.
This is very good for doing all types of reverse engineering, rapid prototyping, anything of the sort, just like what we're fixing to do here. I'm going to be scanning the faces of the intake faces of the cylinder head, getting some China rail information so I can put Kevin's brand new flashy billet intake in CAD. Yes. And it's going to fit exactly like it's intended with absolutely no trimming whatsoever. That's the goal anyway.
And since those of you may know weird engines don't get cool shelf parts because they're not common, like with an LS, you can buy a dual injector LS throttle body flange intake manifold with a burst panel. I can't do that with an Oldsmobile. Like, I can go look on Holly right now and buy one for a big block LS, small block Chevrolet, but there's not anything out there for an Oldsmobile. But Peyton's gonna make me one.
That is why I like to, and I've had several people say that I'm driven out of necessity. That's why I've made some billet heads. If it doesn't exist, we make it exist.
There you go.
So if it doesn't happen, we make it happen.
Cool.
The other cool thing about this scanner is I got this because I'm very interested in the cylinder head side of things. It's always been a hobby of mine. I've been porting cylinder heads since I was 16. I started with a set of Pro Comp Oldsmobiles.
There you go.
To do a 30 over 455 while I was still in high school. And of course that's just been a downward spiral ever since, fueling my bad decisions. So with this, the reason I bought this scanner right here is there are a lot of scanners that can pick up data really fast and over a really large area. Whereas this one has that. I can scan anything from around 300 thousandths of an inch up to about 13 feet.
Oh gosh.
But this has what is called a single line mode, where it focuses all of the lasers in one specific spot. So I can actually get down inside a port and pick up data very quickly, very effectively, and be able to do port and intake digitization. So that was what really sold me on this. So I'm in the early stages right now of trying to get up and going, offering port development, digitization, and stuff like that.
Sweet.
Still in the infancy stages of it. I'm still trying to feel out where I'm actually going with the business, but there's a lot of upside to it. I've got plenty of time.
Well, and tell people where you're at. I know you're on Facebook and Instagram.
I'm in Facebook and Instagram at Performance Driven Design.
Yes.
You can find me there. I'm usually regularly posting of the shenanigans that I get into.
And some of the CNC billet, just amazingness you're creating.
If you like seeing some of the background, I show the design side. I show the machining side. I'm a huge machining nut anyway, so I like seeing the stuff that people don't normally see on the manufacturing side of things. So it is music to my ears hearing a CNC machine over there purring.
Yep.
So that is often what I post.
Cool. Well, I'll put the link down in the description down here too, so you guys can go check him out. And yeah, I've been watching this stuff for a while, and we've known each other through the Oldsmobile world and for years ago, but now we're actually doing something together, which is cool. I'm gonna set up a time lapse so you guys can see what all he does for the scanning process, and then we should be able to look at the file once it's in the computer. Sweet. All right, let's get to it. All right, so I set up a time lapse for this, not really knowing how long it was going to take to do it, and it really doesn't take that long. Talking with Peyton while this was going on, the scanner performs several hundred scans per second. I don't remember the exact number, but it's a lot. And so all of that plots all of the information that it sees, sends it over to the computer, generates an image, all that kind of crazy stuff there. You can see we put a bolt on the passenger side cylinder head to make sure that the angle of the bolt matched, you know, where his scanner was trying to scan down inside the the holes to get the angle of that right, so that when we have the face of the intake, the whole angle matches, so that everything can be tightened up properly once it's all said and done. All right, well, you saw him waving that cool tool around, and we've got something to show you guys in the computer now. And you're saying this is accurate to how close?
Okay, so this scanner is measured in two different accuracies. You have a volumetric accuracy, and you have it's just regular accuracy, which I liken to a 2D shape. So if I'm looking at the face of this cylinder head right here, at worst case, this scanner is accurate to 1 2/10. That is saying at any given point in time, anywhere on this, you would see at worst case 1 2/10 deviation from what it actually is.
That's pretty close.
At best case, if I was to take the entire volume of the top end of this engine, the whole head and everything, I'm looking at worst case of 0.8 of a thousandth. So
wow,
we're holding some pretty tight stuff, which is far more than the tolerance we're actually going to be doing on this.
Yeah, and you guys can't quite tell from this angle, but like,
so
there you go.
You can see
both banks all done.
Now, a lot of you, I'm sure there are some people who are watching this channel who are looking at this and like, oh my gosh, that's just terrible right there. I do scanning for a living, and that's just horrible.
We don't need that down there.
The only faces that I care about are both intake faces and the China rail. So anything other than that, including the valve cover, is irrelevant. All I need is port height from deck of the cylinder head and bolt locations. That is going to give me enough information to accurately place Kevin's intake on top of this. So what I'm going to do now is we will give this an alignment, and because right now it is just somewhere oriented completely difficult in space. I can't do anything with it. If I was to import this into my CAD software, it is not going to have any sort of normal orientation whatsoever. So I'm going to assign some XYZ planes to it and give it a meaningful origin for what I'm trying to do, while we're also doing work in the background. We stay busy down here. We're going to make sure it is exactly what we need it to be, and then we're going to put an intake on it.
Yeah, do you have a sample? I know you have an intake for your engine drawn up, because you sent me some pictures of it.
I can pull up, this is a valve cover that I'm working on for my billet head right now.
Oldsmobile. And I just made that look really funny, getting really close on it.
Oldsmobile. And if I come over here, I can open my intake. It's a little bit slow, even though this is just a supercomputer, given that there's just a lot of CAD data involved in this thing.
Yeah, I bet that some of those things.
Also, some broken stuff right now in SolidWorks, because I've been making a lot of changes to it, still heavily into the development portion of it. So you're looking at a intake right now that is tuned to the 3rd harmonic, and I am looking at turning this engine. I want to see a meaningful power band between 84 to 86. So you can see we have a very short runner.
And this is a naturally aspirated.
This is a naturally aspirated engine. Very short runner, a lot of plenum volume. This thing has almost 850 cubic inches of plenum volume.
Jeez.
There's a lot of math involved in this, and of course you can see fuel injected. That is the only way to go. This is 100% billet bolt together, all O-ringed, all in CAD. That's the only way to go.
That's some trick stuff.
So that's the kind of stuff we do at Performance Driven Design. I'm still young, still learning at a 90 degree.
To already be able to create stuff like that is freaking impressive. Because I'm the kind of guy that back when, I was Peyton's age, like this stuff was super far out of my league as far as price and education level, and now I feel like it's a lot more common, and there's so much more CNC programming stuff happening these days. So you guys coming up through school, like, it's a very good career choice for a lot of people. And instead of just being somebody that sees a chunk of metal and some tubing and like we just create whatever we need to create out of all this mess, but that's the fancy way to do it. And like,
it is most definitely the fancy way to do it. Also gives you some headache from time to time. I'm the kind of person who voluntarily undertakes a very large amount of headache, so I do it to myself. But it has this is the direction that industry is going.
Yeah.
If you're not keeping up with this, you're behind in the CNC.
Well, even in like say for like modern cars, you know, like modern cars are almost completely designed, I would think, in CAD these days.
100%. In my day job right now, through the SEMA garage, we can actually get access, no longer Chrysler, but like GM and Ford, we can get access to an entire vehicle. Everything is 100% in CAD.
Yeah, and it makes it to where like the cars they're repeatable when they build them, and
there's
like
no guesswork involved.
Well, in these kind of cars here, I mean, the frames were like, depending on which welder you got that day, the frames might be different shapes, but you start getting into more modern cars and they're all exactly the same. You can take a door off of one and bolt it right on, and it fits exactly like the door you took off the car, or you know, any other part of the car. And then you look at how intricate the designs of, one of the things I remember was like air conditioning vents in behind the dash, where they have all these planes and these little holes to snake through, and they CAD design all of that. Time to go pick up kids from school. They have CAD designs for all that, and they can design that duct in a program, figure out the molds or the printing or however they're going to do it, pop that piece out, and it fits right where it's supposed to be. And it's just trick. And
it is trick.
Seeing something like, we're going to have something like that on my Oldsmobile motor.
Yep.
Super cool. Super cool. But, well, I got to wrap this video up and go get my kids from school. But you guys go check out Peyton.
It has been a pleasure. I want you guys to remember 3 things when you think of PDD: performance, precision, and unparalleled perfection. Kevin, it has been a pleasure.
Yep, man.
I'm looking forward to working with you.
Heck yeah.
Let's make some cool stuff.
Yeah, you guys, I mean, I'm not gonna rush him because he can do this in his own playtime, but something to look forward to on the channel. All right, well, I'm back from picking up my kids, and that's gonna wrap up this video. Kind of wanted to have a little bit more polished of an ending for this video, but that's how these things go sometimes. Had to run out and get my kids. Peyton's on his way back to Tennessee, where he is going to work on the CNC programming for my intake. So one thing that I think is really awesome about you know, Peyton is seeing his drive and motivation as a younger guy. You know, I'm 42, he's 25, and seeing his passion for the stuff that he's doing in the motorsports world, I think is awesome. It's great to see that, you know, younger guys are still involved with this stuff and, you know, being excited about it. A couple of my guys in the shop are pretty young. You know, CJ and Eddie are both pretty young. You know, to see younger people get involved and continue to be excited about motorsports is something really exciting. And I'm really excited to see what he's going to do for an intake manifold design. We're going to work together on some things. He's going to engineer it to where there's already a built-in throttle cable mount for the Motion Raceworks throttle body that I'm going to run. So all kinds of neat stuff that's going to all be done in a computer for my little engine here that is just a modern way to do it. And like I kind of said earlier in the video, we're kind of just a shop where we just put her together and send it. We take raw material and either bend up tubing to make roll cages, or when it comes to fabricating brackets and stuff, we just kind of make it happen. We've got our old school manual mill over there, same with the lathe. But to have something that's going to be all like the way he laser scanned this thing, and then it's just neat. So anyways, I'm going to leave you guys with that, and we'll see you guys in the next one.